So let's talk about, the Kubernetes architecture. Now, again, we all are must be aware, right? If we have ever seen the Kubernetes architecture, right? That Kubernetes architecture. So I've not explicitly put up the architecture here because I want you guys to visualize that architecture and put it in your mind for forever, right? So think you have to just create two things, right? You have to create one block on your left, one block on your right, not on a pen or a paper, in your mind. In your mind, you should have one block on your left side of a brain, and other block you should have, sorry, another block you should have on your right side of a brain. Now, when you say the left side of a brain, right, let's keep master node as my left side. And at right side, let's keep worker node. Okay. Now, master is what? By the name, right? Master is master. It is the brain of brains, right? Which basically takes care of everything, which controls everything, which has a command to ensure that all the resources, all the stuffs are in managed via this way. Worker is what? It is a instruction area, right? Where whatever instruction it is getting from this area, that is master, it will make sure that it follows all those instructions. So master and workers are joined together and they ensure that whatever the instruction we are getting from the master, worker has to fulfill those instructions or those demands. Now, the another important part is, which is very important from a production perspective, that it is always recommended to have your master in a high availability. Okay, I'll tell you why. See, it's like, that when we say master, right, that as a brain, we refer master here as a brain of a cluster. Now, if one brain failed, what will happen? There is entire application or entire components of the things which are running, they all will go down, right? So to ensure that your all the Kubernetes is always up and running and it is always good, you basically set up your master as a high availability component. Mean you have 3 or 5 master nodes actually, which all are into the different availability zones, different areas, not in the same data center, because you ensure that they are in a different zone, different area, so that if anyone fails due to any ABC reason, you can have it installed or you can have it set up in some other zone. Now, your master, right? So again, let's come back to master only, right? Let's just keep the things on the left side of a brain and we'll understand the different components which master contains. Your master contains API server, scheduler, HCD, and the controllers. It contains the 4 major components: your API server, your scheduler, your HCD, and your controllers. We'll talk about all of these components in the detail in the next slide. Now, so, as I said, right, that Kubernetes architecture is divided in 2 components. One is your master node, other one is your worker node. Now, when we talk about different components, right, one is the API server, second is the scheduler, then you have HCD, then you have controller. When we talk about API server is something with which you interact very much every time. Every time you run kubectl, you run the kubectl is a command, is a utility through which basically you get the information or you interact with the Kubernetes cluster. So this is the cluster. This is basically kubectl is something which allows you to interact with the Kubernetes cluster. It sends the commands to the cluster via the API server and gets the request from the same. The second is the scheduler. Scheduler is nothing but it is a component which ensures that which basically assigns the nodes for your application. Within the cluster you have multiple nodes being added. So with that, it assigns the different nodes for your application on which it has to run. Now, HCD is again something, it's just basically the database, or it's you say the inventory, which basically stores the state of all the clusters and all applications. Whatever application and clusters, whatever applications and whatever the cluster state is there, whichever is running inside that cluster, that those all information will be stored in HCD. And controller is something which is basically controlling or helping you to manage the things, allow you to integrate with load balancers, with storage, with cloud services and things. Let's talk about all of these things a little bit more and understand, right? Now, API server, right? API server is what? It acts as a front end, okay, for your Kubernetes. Kubernetes master is nothing. You can call it as it has a control plane. API server acts as the front end for your Kubernetes control plane where it exposes the communication with the cluster and it validates that whatever the process is, whatever the request you are making, all of those things are basically you are getting a right response. On top of all of these, it also does very important, one of more important functionality which you can make a note of, that it updates the state in the HCD2. This API server is a component which is responsible to update the state of Kubernetes in the HCD. For example, when you run kubectl apply minus f any pod name, right, or any pod definition, or you say that kubectl run and you run the pod, right, or you run the pod is basically nothing. It's one of a smallest component, right? We'll talk about that too. That is nothing. It basically does what it now S is running, right? A new thing has started. So it also sends an instruction to HCD that, hey, I have run a pod A and the current state is running. So that is how it updates the state in the HCD. HCD is again nothing. As I said, it's a database, it's a data store, it's a inventory, which has a key value kind of a store, right? Sorry, which has a key value kind of a store, which basically act as a clusters database where all your state, all your metadata of cluster and configuration data is stored. Three things are stored in HCD: your configuration data, your metadata, and your state of the clusters. Configuration data, state, and metadata. Another component, I'll also share these notes too, so don't worry if you are missing anything. Now, think from the controller manager, right? Controller manager is something which ensures that the desired state of the cluster resources, right? The desired state of the cluster resources is maintained. How it will maintain the desired state? By keeping an eye on HCD, by keeping an eye, by watching the state in HCD, because states are stored where? In HCD. So HCD is this. This is where all my states are stored. Controller will keep an eye on this. It will keep looking on this. Oh, okay, HCD, the state is changing. As soon as the state will change, controller will ensure that your desired state of cluster resources are also getting changed. It manages your node controller, your nodes basically, and we call that as a node controller, which makes sure that your nodes are always in a healthy state, right? And it tracks the node status in the clusters, state of the nodes in the cluster. It manages your deployments. Deployments means it ensures that whatever the replica you have written, whatever the desired number of pods you have written, those are always up and running. It also manages your job controller. That is, whatever the batch jobs, whatever the cron jobs we schedule, all of these things are managed via your controller. So it manages three things for us: the nodes, the deployments, the batch jobs, the cron jobs, or simply a job. Okay. And the last component in the master node is scheduler, which ensures that it assigns the pods to the node based on the whatever the resource availabilities are there and the policies. Now, again, your resource availability and policy means, or assigning the nodes to the right pod means that it includes the different factors which are added in that are your CPU, your memory, you have a different node affinity rules, you have a taints, you have a tolerations. These are the buzzwords which we will talk about later. But these are the different things through which basically we uh, scheduler assigns the node. Okay. Okay, so as we talked about, the different components, right? That API server, the scheduler, the etcd, and the controller. So we'll move forward, to the worker nodes component also, right? And we'll discuss a little bit about the components which are important or which are there in the worker nodes. Now, on worker nodes, are something, which basically runs the workload, right? Which runs your application. Now, as I said that as it runs the workload, right? So it also provides the runtime environment, right? It provides the runtime environment for the application. Now, the runtime environment is what? That is basically the CRI, right? That is basically what? The container runtime environment, right? So it has a containers, right? Which basically act as a runtime environment for these applications. Now, apart from that, it also has two other components like kubelet, right? Or you have the uh, this thing kube proxy, right? And the pods which are running, very important part. Now kubelet is something, it is basically the agent. Okay, kubelet is an agent which runs on each particular node, and it ensures that the container or the pods which are defined, right? Rather, I would say that containers which are defined in pods, right? Containers which are defined in pods, they are into the healthy and running state. So kubelet is an agent which is running on each node, and it ensures that the containers which are defined in the pods, they are into the running and healthy node. It also like it key it just communicates with the API server to fetch the pod definition, right, and report the status. Means if contain or the pods and things, whichever you see the status, right, that they are healthy or not, or the status. So that basically kubelet keeps on fetching those data. Now we'll talk more in detail about all of these components, but before that, let's talk about kube proxy. Kube proxy is one of a component which basically manages the network rules, right? Which manages the network policy on all the nodes. It ensures, sorry, it ensures that all your communications between your pod, between your services, uh, s- uh, and your external network. So whatever the components we define, like your pod, like we have services, we have the external networks, right? The load balancers and other things, ingress rules. So all those communication happen in a seamless manner. That is basically taken care by Kube proxy. It implements your load balancer and everything. Apart from that, container runtime is something, it's a software, right, which runs the containers. Container runtime is nothing, it's a software that runs containers. So again, guys, this component is, very, very important, because there are sometimes, in the companies, like you go for a PayPal, you go for a Palo Alto, you go for the other big companies, they will make you confused on this entire architecture itself, right? Because there are so many things, there are so many stuffs which they will ask, right, with respect to architecture, that it's very sometimes becomes difficult to get ourselves very, very clear in that which component does what and how is it actually related to the other components, or what will happen if that component is not running. So container runtime is nothing. It's basically the software which runs the container. For example, earlier it was container D, like you have a to now you have Docker also, you have CRIO. So anything which basically help us to pull the container images and run those container, that is basically your CRI, container runtime. And that is very important component. It's a very important component to have it running. The last one is the pods. Pods means nothing. It's basically the smallest deployable unit in the Kubernetes. Means it's just one of a smallest unit, right? Which basically does what? It encapsulates or it contains your containers, right? Either one or you have multiple containers. All of them will be in your pod only, right? Which basically share your storage, share your networking rules, share your configuration and everything, right? And then further, it is managed by the different Kubernetes objects. Like you have a deployment, you have a daemon set, you have a stateful set, replica set, anything, all of those does what? They manage your pods only. Okay. Now, Kubernetes, it uses a very flat network model. Kubernetes uses a very flat network model where for every pod, it gives you a unique IP address. For every pod, it gives you a unique IP address. And it ensures that all the pods which are there, right, they are basically having the different communication mechanism. That is your cluster IP, your node port, your load balancer. Cluster IP is something internal to services. Node port is exposed on the node IP and the ports. But the load balancer is something which you can integrate with the cloud providers, right? That you can integrate with your cloud providers. So worker node has container runtime, the kube proxy, the kubelet, and the pods. Okay. Okay. Now we'll talk about one more quick thing, right? The architecture flow, right? At how the Kubernetes architecture flow happens, right? Now think from this perspective. Okay. Let's talk from that you are on a pizza shop, right? And what happens, right? That pizza shop, you take there is a person who takes an order, right, at a front desk, right? That is the API server, the front desk where you go and you order. What you do basically, you make a request, right? And whatever updates, whatever thing you have to take from that front desk only, right? It will give you the response also. Now when you do request and response, so that uh, pizza guy will do what? As soon as it has made an order, right, it has taken a request, it will update to whom? It will update to the HCD, right? That this is the state you have to now make, right? You have to make this particular pizza, right? HCD, and also scheduler will immediately see that okay, there is some requirement coming in. It will schedule to the particular resource, right? To the particular person in the kitchen, whoever is making pizza, right? So it is basically assigning that pizza to the node, right? That will prepare the thing, put it up, and it will do what? That it will basically uh, update back to the HCD that this is good. We have updated. It is in running state. Now API server is giving you the response. Your pizza is ready, right? It's a running state, right? You can take your pizza. Meanwhile, in between, controller manager, kubelet, they are doing what? They are ensuring that your pizza is ready. So it is assigned to the right person, right? It is basically it is running on the right way or right things, right? Or it has all the good stuffs and things. Controller manager or the other, controller manager is nothing like a quality check person, right? Who ensures that everything is good, right? Your pizza has the right toppings, it has a right in a right way, it is cut, right? It is not uh, burnt or something, right? So it basically mentions that all of those things are there. And then at the end, you have a kube proxy, or it's like a the front desk guy, right? Or delivery guy who basically ensures that he delivered to the right person. Okay. So in the similar fashion, when we have this architecture flow, it has a resource definition where you say that user defines a desired state, right? That this is a resources you have to put in. Then you have a API server, then where you process all the requests and update. Then you have, sorry, then you have schedulers where you assign the pods to the different nodes, right? And you have a kubelet which ensures your pods are created and running on all the nodes. And then you have a controller manager who ensures that all the resources which are there, they are maintained in the desired state. And the last is a kube proxy. So this is basically the architecture flow. This is how the Kubernetes, the different components, when they start by creating, when you start creating a resource, from there they flow until the network communication.